So I think we can start with this second session of the day, and we will have 4 presentations after to go with a coffee break. So the first presentation and the first speaker is Remo Grillo. The title of the presentation is Understanding Questions, Natural Language Queries and Knowledge Graphs. So stage is yours.
Thank you very much. So understanding questions. It's interesting how we ended yesterday's session because we had a very nice conversation about what I'm about to talk in terms of how to make questions to knowledge graphs as a natural interface to access data. And in fact, these problems we mentioned yesterday, in the end, I think had a pretty sophisticated answer, but we can condense it with a effective, but maybe some other kinds of interfaces might work. So what I'm about to talk today in the next 15 minutes will be, first of all, problematizing what are the limits of knowledge graphs in general in this regard, and also the problem of making questions to a knowledge graph, so questioning in that sense. Then the conceptual approach on what makes a question correct. What does it mean? Because an answer can be correct, but what about questions? And then I will propose an application, which is something I've been working on for my first year of my PhD research. And in particular, I would really like if you provided feedback questions, because I can improve it. So let's start. Let's define the problem. This is, I think, particularly true in cultural heritage, because the interactivity is not exactly perfect, because especially humanists should kind of know what they're doing when they're doing Sparkle queries, or in any case, they need somebody who can develop software to create facades for data. And accessibility, if you look at the raw graph, is not exactly intelligible, let's say, the contents. And the interoperability is a promise of the semantic web, but very often disappointed. And there's this Babel effect where everybody speaks their own kind of language, and the completeness is not guaranteed many times, because it's very painful to, it's a long process to write data in triples or create forms to insert data. And therefore, very often data is missing entirely, and the ETL processes are very long. So now everybody's talking about this, because LLMs promise to achieve everything that knowledge graphs like bare data couldn't, because it's very easy to talk in a natural language, of course. You can use as many languages as you want. You can even use images. You can create images, or you have a dialogic interface, which is something you do with humans always, every day, and it's very flexible. You don't need to force your language, ideally in a formal one, right? So everything is solved apparently, but maybe not, because LLM's answers are uncertain. They're expensive as hell to train and to make inference out of it. You don't know what's going on behind it, even though they try using explanatory AI to solve this problem. And the reasoning behind it is statistical, is stochastic, and therefore is fuzzy. And it's full of it's full of rubbish. So garbage in, garbage out. The source of data comes from people, very often denying their privacy and gathering data from them. And the problem is also that people are wrong most of the time, and most of the time they're stupid. So data coming out is false, and there are some memory problems technically with LLMs due to the needle in a haystack problem and many others. So the idea behind my research, the research question was, can we combine the good parts of interacting with knowledge graphs with the easiness of LLMs in terms of accessibility? And the natural thing was let's make natural language to knowledge graphs and see how it can be done. But now that it comes the conceptual part where you ask yourself, what makes a question correct? Again, answers are easy to evaluate, let's say, are easier to evaluate, but what does it mean that a question is correct? And personally, I've identified these 4 dimensions. The names are made up. I like syntactic, lexical, ontological, and semantic, but just made it up. But what do I mean? By syntactical correctness, this is obvious, because a query is syntactically correct when it satisfies the syntax of Sparkle. If you miss a bracket, the Sparkle query will not run, and therefore it's not correct. That's obvious. That's easy. So, but then lexical correctness means something a little bit further different. So you might have a perfect Sparkle syntax, but you're using classes that do not exist or properties that are just made up because LLMs hallucinate, and therefore you can be syntactically correct, but not lexically correct. You're using terms that do not exist. Is that all? No, because ontologies have constraints, ontological constraints or logical constraints, which means that you can use a perfect syntax. You can have properties and classes that actually exist, but you're putting them together in a way that contradicts the rules behind the ontology. So we need to check that too. That's the ontological correctness. So we have these 3 kinds. We have a perfect Sparkle syntax. We only use classes and properties that exist, and we mix them in a perfect way. So we are ideally sure that the query is correct, but this is wrong. Now, let me take a step back before introducing the 4th kind of correctness with this question. And it's an old problem in philosophy. If you take this question in natural language, it's grammarly and syntactically, and also the words do exist, and they're put nicely in a sentence. It's meaningful, it means something, and yet something is wrong. There is no king in France, and therefore it doesn't make any sense to ask whether he is bold or not, because questions are, in a way, claims under disguise. They embody worldviews other than factual assumptions. And so even if it makes sense, it can be badly posed, and it all depends on the context. Because let's say if we ask this 300, 400 years ago, that would have made sense, but not today. So in our case, it means that semantically correctness is relative to the specific object of question. So it's semantically correct only if the question itself or the query itself shares the knowledge pattern that I expect inside the graph. In other words, an answer must be possible, at least, even if it can be empty, but it must be possible. And that only depends if I'm using the same knowledge pattern. So what have I done to achieve this? Let's see some applications. The state of the art, very, very, very simplified, currently employs the vectorization of, or the embedding of the entire graph. A way to do this is you translate all triples into sentences and you make vectors out of them. Or, and then, of course, you make questions on the vectors and you retrieve the best results, you expand and you try to do something. But then you lose the structure knowledge of the original graph because you move them into the vectorial space. That's a simplification. Or you know that the graph is in CDOC-CRM mostly or completely, and then you provide the LLM the usual patterns that you use with CDOC-CRM. But what if it's not a CDOC-CRM, or it's a mix, or there are different versions? That's problematic. So my how to fight blindfolded my goal was to build a system that it's ontologically agnostic, therefore it uses in-context learning and only requires the Sparkle endpoint. The previous solutions, for example, the graph frag, required you to download the entire knowledge graph. Sometimes it's too big to do it. So I wanted to do something that worked out of a single Sparkle endpoint, and it integrates the 4 correctness checks I've talked about previously and gives transparent answers. And I've called it Kraken because I liked it. And it stands for question, respond, something. I still have to find out the meaning of the 2 letters, but I like the name. That's it. And so you'll help me find a name for it. Let me show you a small demo of what I do. You upload a tentacle file, and by the way, what the fuck's a tentacle file? That's what I just uploaded in the interface. It thinks about it for a while and gives an icebreaker message about the graph. How does it do it? We don't know yet. I'll explain. And you can ask a question like, show me the work. By the way, this endpoint is the Smithsonian Art Museum knowledge graph. Then it produces an answer by the question. And then it's also possible to inspect the natural language query translated into a Sparkle query. So you can see how the system is. And of course, also the answer is structured originally, and there is a translation in natural language. Then you can take from there and ask 3 minutes, and can ask other questions that are contextualized from the previous ones, and the system will understand that I'm talking about William Zorak without explicitly mentioning him. How do I do it? Tentacle file, what was that? It's basically a distillation of the entire graph. Originally, the graph was 90 million tokens. And if you provide an LLM with this amount of triples, you will spend about $1,000. So you cannot just take the entire graph and ask a question. You need to distill it. This is what has been done here. And it's basically an exploration of the graph. You take the knowledge pattern using some heuristics and walks in the graph, you capture them, and you make a small package that is distillation. And it's just about 9,000 tokens for a graph that is this big. And it contains also a co-occurrence matrix with deterministic connections of all the classes and all the properties, which is very small to do because classes are limited, even though the graph is huge. Let me show you another example on how to make the distillation of the graph. 2 minutes. You give the endpoint. You can set a certain amount of classes you want to distill or extract, the depth of the exploration for each class to show the depth of each pattern, all kinds of stuff for advanced extraction, which are optional. You can blacklist some classes if you're not interested in them. And then the extraction runs. This needs to be done only once. So if you want to provide a chatbot for your knowledge graph, you do this once and hopefully for all. Then when it's ready, you can see the extraction and the tentacle file. This tentacle file is then used later. It contains all these patterns and some examples from literal values. So the LLM is able also to understand which kind of content the graph has. All right. Yeah. Some other examples. Never mind. I want to show you something else. In this case, the graph is much bigger and much more complicated, and the question is much more vague. Therefore, I expect the system to make a mistake. In fact, the iterations, there is a number there which says 2, which means that it took 2 attempts to refine the query. Okay? And I'm able to inspect the entire process of the iterations. This is the first attempt, but in this attempt, there was a problem. And the problem is that it didn't respect the data model. We made a we made a check, and we repeated providing the previous error message and asking the LLM to retry to build the Sparkle query. That's how he did it. Also, he checked for other stuff too. This is a huge, complicated thing, but in the end, it's just the natural language question that goes into chatbot interface, in the other module, it's asked, etc. And my 15 minutes are over, but the knowledge graph distiller is a process you do once, and then there is the second part with the user. Yeah. Oh, done. Okay. So questions for the next 5 minutes, please. Also feedbacks and suggestions, whatever.
Thank you, Remo. So some questions. We can use it like this.
Thank you. Instead of distilling the graph, have you tried with graph embedding techniques?
Yeah. The problem is
there are some graph embedding techniques that respect the structure.
Okay.
So you can embed both node properties and edges, connecting nodes.
Yeah. The problem.
To some extent.
Yes. And it's a path I explored, but maybe I was wrong to go somewhere else. But the problem I found is that you need to have the entire graph on your machine and then produce embeddings.
Yeah.
Which was something that was just not possible in my case for some graphs. They were too big and they were not mine. And I wanted to see if I was able to find something that worked out of the graph itself, let's say. But that's, yes, it can be done. And
yeah, yes, you must have your the graph on your machine, the full graph.
And also, if something changes in the graph, you should kind of redo the embeddings, which is very expensive.
Doing the distilling. Yeah.
Ideally, not ideally, because you extract the shapes, not the content.
With the distilling, you mean?
Yeah, that was the goal. So, like finding a way to say that an artwork has this shape in the graph. And so, if a new artwork comes and gets added, I already have the shape for it. While on the vectors, you kind of have to find it. I don't know, but
depends.
Yes.
On the node properties. If the node properties are changing, or the structure is changing, then you have to recreate the graph, recreate
the embedding. Yes, yes. Thank you.
You have to deal with some performance issues also, like you have done.
Yeah.
Other questions?
So my question is, given if you can turn back to the critical file, in the examples, were the examples something that you had to add because you noticed some change in performance, or are they there just to ensure the model knows what it is about, and how much does that impact on the retrievability? Like if I ask an about some entity that is not inside the examples, will it still be managed to get enough context from the previous? And the second thing is, how do you deal with the unification in the case of, for example, I ask a question about a concept which is slightly different in the graph, but it's still that. Can the model find still the labels that are attached to a variety to perform the reaction period? I don't know if that's clear, but we can talk.
The first question is very clear. The second one a bit less, but we can. So the idea is that the statistical file must be representative for the entire graph. First of all, because the co-occurrence matrix is a list of all the classes, all the properties, and all the connections possible ever in the graph. And it's relatively small because the graph can be huge, but classes are 50, 40, and then you can kind of compact. And this is used to check deterministically that the question makes sense in that regard. But you need examples, and therefore you use patterns. And the patterns are made in such a way, ideally, as it still has to be perfect, but in such a way that with them you can cover the entire graph, that no portion of the graph is out. So far, for graphs that are kind of manageable in size, I have to test it. I have to make a proper evaluation of this, but the idea is that it must be representative for the entire graph. And the second question, we should probably talk about it later because I probably ignorant about that specific thing. That's right.
Okay, thank you. I think we have one quick question. Okay. Do you want? Okay. You want to use the microphone?
Oh, yeah.
Ci arriva? Sì.
So thank you very much for your presentation. Very quick question. I have some more to discuss later. Can this distillation highlight also some kind of usage of ontologies in the graph?
Bad usages?
Yeah.
Definitely. Yes, because it's not in the demo, but I've made also a thing that, sorry. Yes, you can provide an OWL file, for instance, and check whether what you found in the graph corresponds to the rules of the ontology itself. But the system is tolerant, meaning that if there are mistakes, I must be able to find the results anyways. Even though there are mistakes or things are not perfect, which is always the case, even if in our projects we did together, there are lots of mistakes, and we want the user to retrieve the answers, even if we're bad ontologists, let's say.
Okay, so thank you, Remo. Thank you again.